Hi, in this video we're going to look at linear inequalities of one variable, and a linear inequality is just a statement involving one of the inequality symbols, so less than, greater than, less than or equal to, or greater than or equal to. The way we solve that or find the solution set is similar to how we solve equations, with one exception, and that exception is that if we have to multiply both sides of an inequality by a negative number, so this C here is a negative number, and we have some inequality, it says A is less than B, then if we multiply that number on both sides of the inequality, we have to switch the inequality symbol. Right? Why is that? Well, if you think of an inequality that is true, let's say we know 1 is less than 5, and we multiply both sides by -1, that leaves us with -1 and -5. Now it's clear that -1 is no longer less than -5. We have to switch the inequality here. So at least in this particular example, we can see that if we multiply by -1, we have to switch the inequality symbol. It's true in general as well. Okay. So let's take a look at solving a linear inequality of one variable. So here's one. We have 1 minus x divided by 5 is greater than negative x, the opposite of x, divided by 10. Okay. So we're going to solve this, and I think the first thing I want to do is to get rid of the fractions, right? We don't like fractions. If we can get rid of them, and when we have an expression or an equation or anything like that, where we can manipulate both sides, we can do that. And so what I'm going to do is we're going to multiply by 10, because 10 is the common denominator here. It's the least common denominator. And we'll multiply both sides by 10. Now, since 10 is a positive number, we don't have to worry about switching the inequality symbol. It will remain the same, and it will remain greater than. Okay. So I'm going to multiply by 10. And then on this side, we have 10 times this fraction. The 10 and the 5 leaves a 2. So I'm going to have 2 times 1 minus x is greater than, and the 10's cancel here, so opposite of x. All right. Now, this is much nicer, right? It has no fractions in it, and we can now solve this inequality. Okay, so we'll distribute the 2. 2 minus 2x greater than opposite of x. And now we'll add the 2x. So we have 2 greater than x. Okay. Now there's various ways we can write the answer. This would be 1. Another one would be to write the interval notation for the answer. And so we know that x here is less than 2, or 2 is greater than x. So we can write the interval -infinity to 2, parentheses for the infinity always. And then since the inequality is strict, we will use a parentheses. If it was non-strict, like or equal to, this less than or equal to, greater than or equal to, we'd use a bracket. Okay, another way we could represent the solution set is with a number line. So here's 2. And then we highlight the region that represents the answer. Get the color. So we're going to use a parenthesis here, as we did in the interval notation, and then highlight the region that represents the solution set. That would be all the values that are less than 2. Okay, so we've solved this inequality. Let's look at another one. So here we have 8.5y minus 3.5 is greater than or equal to 2.5 times the quantity 3 minus y. Okay, this inequality involves decimals. And again, if you don't like decimals, we can do the same thing as with fractions. We can multiply by something that eliminates the decimal. I would encourage you to do that. In this case, we want to move the decimal point just one place over, so we'll multiply by 10. All right, so all of this side gets multiplied by 10, so we're going to have 8.5y, multiplied by 10 of 85y, minus 35, greater than or equal to 25 times 3 minus y. All right, so the decimals are gone, and we just have, well, really natural numbers here. Okay, this 10 had to be distributed into this difference, right, because that's the left-hand side. The 10 gets multiplied by the 2.5, but we do not put it in here because this is all a product. So this is 10 times this times 2.5, and we just evaluate the 10 times the 2.5. Okay, all right, from here we can work towards solving it. So 85y minus 35 greater than or equal to 25 times 3 to 75 minus 25y. All right. So let's add 35 to both sides, and let's add 25y to both sides. Now, in all of these operations, right, we are not multiplying by a negative number or dividing by a negative number. So we don't have to worry about changing the inequality symbol. Right, so we have 110y greater than or equal to 110. It's nice. Divide by 110, which is a positive number. So the inequality symbol remains the same. Y is greater than or equal to 1. Okay, interval notation. So greater than or equal to 1, we have 1 to infinity. We use brackets because the inequality is non-strict. The solution set will include y equal to 1, in other words. Okay, and we can draw a number line solution as well. So here's 1, and then we want to start at 1 and go to infinity. So I'll use a bracket here and highlight the region that represents the solution. Pardon the squeak. There we go. Okay. Other ways you might see this solution written, or at least the number line solution written, is with a closed dot here at 1 or an open dot here at 2, depending on whether the inequality is strict or non-strict. I believe the Hawks uses the parentheses and brackets, but you may see others in other books or other classes.